When an AI whips up some incredible image or drafts a perfect email, it's easy to picture this brilliant digital brain just thinking. But what if I told you the real secret, the most important part of the whole process, has almost nothing to do with the fancy code? Let's pull back the curtain on the massive hidden effort that truly powers artificial intelligence. There's this old school saying in computer science that just nails AI's biggest challenge: garbage in, garbage out. It's so simple, right? The quality of what you get out depends completely on the quality of what you put in. And for AI, that in is all about data. Getting that data right, well, that's the most expensive, time consuming, and overlooked part of the entire game. So, to really get why good data is so hard to come by, we have to start with this problem that plagues pretty much every company trying to do something cool with AI. It's a concept they call data debt. And just think about that word for a second. Debt, like financial debt. Data debt is what happens when you take shortcuts and let things slide for years and years. Just imagine it. Decades of different computer systems, messy spreadsheets from that company merger 10 years ago, outdated processes. It all gets tangled together. This isn't just a messy closet. It's a huge anchor weighing the whole company down. And believe me, this isn't just a headache for the IT department. It's a massive business problem. This debt slows everything to a crawl. It opens up scary security risks, and it just bleeds money as people waste all their time trying to track down and fix basic information. The bottom line is pretty clear. Before you can build the shiny future of AI, you have to pay down the messy data debts of the past. So, okay, if data debt is the problem, what does it actually take to fix it? Well, the answer might completely change the way you think about AI. Get ready for this, because it flips the whole script on what AI work is. A jaw-dropping 80% of the work in any given AI project has absolutely nothing to do with building the brain or writing the cool algorithm. 80%. It's all data engineering, that grueling, unglamorous job of cleaning up the mess. The sexy part, the part we all think of as AI, that's only the last 20% of the job. So let's spend a little time inside that giant 80%. Let's take a look at the factory floor, where raw, messy data gets refined into the high-octane fuel that artificial intelligence needs to run. This whole process, this factory floor, is called data preparation. And it's not just one thing, it's a whole series of really intensive steps: cleaning, transforming, and basically wrestling information into shape. The goal is to turn that raw, chaotic data into a pristine, perfectly organized data set that a machine can actually understand and learn from. I love this analogy. Think of it like an oil refinery. First, you have to ingest the crude data, right? Pull it in from all over the place. Then comes the most important part, the cleaning, where you get rid of all the gunk and impurities. After that, you transform it into the right format, the right structure. And finally, you might even augment it, enhance it, to make it even better. Every single step is absolutely essential to get that final, valuable product. Let's just zoom in on that cleaning step for a second. This is the truly unglamorous janitorial work of AI. We're talking about hunting down duplicate entries, fixing typos from 10 years ago, and getting rid of noise, like a blurry spot in a photo or a bit of static in an audio file. It's tedious work, for sure, but it is so critical because every tiny error you fix here makes a huge difference in how well the AI performs at the end. Okay, so cleaning your data is one massive challenge, but what happens when you've done all that work, you look at your nice, clean data set, and you realize you just don't have enough of it to train your model properly? This is where a really clever trick comes into play, called data multiplication. Let's say you only have one good picture of a cat. How can you possibly teach an AI what all cats look like? Well, you multiply your data. You can take that one image and rotate it a little, flip it horizontally, or even just tweak the colors. For an AI, each of these tiny changes looks like a brand new cat picture to learn from. It's an amazing way to expand your data set without ever leaving your computer. All right, now for what might be the most surprising part of this whole unseen process. After all this technical work of cleaning and transforming, the most critical ingredient is often, well, it's human. I mean, really think about it for a second. How does a machine, a piece of software, learn to recognize something as complicated and varied as a cat? It can't just figure it out on its own. It needs a teacher. It needs someone to show it. And that is exactly where data labeling comes in. For an AI to learn what a cat is, a person, a human being, has to sit down and manually go through thousands, sometimes millions of images and apply a little digital tag, a label that says cat. This labeled data becomes the ground truth, basically the answer key that the AI studies to learn. Without this gigantic human effort, the machine learns absolutely nothing. So who on earth is doing all of this painstaking work? It's a huge global industry. Sometimes it's a company's own employees. Other times, they hire special firms or use a massive workforce of online contractors. But there's another hidden workforce that you might find very familiar.
Have you ever been trying to log into a website and had to prove you're not a robot by clicking on all the pictures with a traffic light, or a bus, or a crosswalk? Well, congratulations. You are working as a data labeler, most likely helping train a self-driving car's AI. Millions of us are contributing to this process every single day, and we don't even realize we're doing it.
Okay, so after all that work, the cleaning, the multiplying, the labeling, you finally have a trained AI model. But how do you actually know if it's any good? Well, it's time for the final exam.
This super important last step is called model validation, and it's all about testing the AI with data it has never, ever seen before. Why? To make sure it didn't just memorize the answers from its training data, but that it can actually apply what it learned to new situations out in the messy, unpredictable real world. Here's how it works. Before any training even starts, you take that big, beautiful, clean data set and you carefully split it into different piles. The biggest chunk, usually around 70%, is the training data. The other smaller piles, they get locked away in a digital vault to be used for testing later on.
Now, there's a really important but subtle difference between these two testing piles. The validation data is kind of like a practice quiz. You use it during the training process to check in, see how the model's doing, and tweak it. But the test data, that's the final exam. It stays locked away until the very end, and you only use it one time to get a final, honest grade on how that AI is really going to perform. So the next time you see an AI do something that just seems like magic, maybe pause for a second. Will you see the clever algorithm? Or will you see the invisible factory behind it all? The mountains of data and the immense human effort that was needed to clean, transform, and label it, all just to make that one moment of magic possible.